Okay, we have 3.4 multiplication of matrices. I think you should have found matrices quite simple up to now. Okay, this portion will probably be the most difficult thing, right, for the topic of matrices, where we have to multiply two matrices. Okay, but not to worry, let's go through it slowly. I will just use the exercise 3.4, okay, to show you what to do now. So first and foremost, what I do here is I write down exercise 3.4. I start at question 1C. Later I'll also do 1B and 1D for you all. So I have this. Okay, the very first thing, right, before we can even multiply matrices, we have to write down the order of the matrices. So for example, this guy is 2 rows by 3 columns, so his order is 2 by 3. Okay, next guy, right, he is 3 rows, 1, 2, 3 by 2 columns, so it is 3 by 2. In order for matrices to be multiplied, okay, you write down the order in this way, and then their middle numbers must actually match up. What I mean by the middle numbers, notice that this number here is 3 and 3. So if these two numbers actually match up, then yes, these two matrices can be multiplied. Alright, and then the resulting matrix order, if the two middle numbers are the same, we just cancel out the two middle numbers. Then we look at the first and last number. The resulting matrix will be a 2 by 2 matrix. Alright? Okay, now 2 by 2 matrix, so therefore I have a matrix here that will be 2 by 2. Notice that this guy here is row 1, column 1. This guy is row 1, column 2. This guy here is row 2, column 1. This guy here is row 2, column 2. Okay, so now when we multiply, we employ something called run and dive. So this first element, row 1, column 1, we take row 1 from the first matrix, column 1 from the second matrix. So row 1 from the first matrix is 3, 1, 2. Column 1 from the second matrix is negative 1, 0, 5. So we'll employ something called run and dive. Okay, what I mean by run and dive is this: 3, 1, 2. They will run and they will dive like this. So this is running. Okay, let me draw one stick man there. Okay, and then you will dive. Okay, so run and dive. 3, 1, 2 will become 3, 1, 2, and then we have column 1 from the other matrix, negative 1, 0, and 5. So what happens here will be this. Okay. What happens here is we will take, okay, can't really see the calculator screen, never mind. 3 times negative 1, 1 times 0, and 2 times 5. So in order to get row 1, column 1, what I do is 3 times negative 1 is negative 3, 1 times 0, I add that is 0, 2 times 5 is 10. So row 1, column 1 becomes 7. Okay? Now we do row 1, column 2 of the resultant matrix. Row 1, column 2, again row 1 I take here, and column 2 I take from this side here. So row 1 I take from the first matrix, column 2 I take from the second matrix. So same thing, 3, 1, 2, run and dive will be 3, 1, 2, and column 2 is 0, 7, and negative 8. So what I get is 3 times 0 is 0, 1 times 7 is 7, 2 times negative 8 is negative 16. Negative 16 minus 7 plus 7, okay, will be negative 9. Okay, now we go to row 2, column 1, row 2, column 1. So it's 4, 2, 6, run and dive. So it's 4, 2, 6, and column 1, -1, 0, and 5. So what we have here, it will be -4 plus 0 plus 30, which gives me 26. Finally, row 2, column 2, you can try it out on your own. I will just give you the answer. It will be 14 minus 48. It's actually -34. And that's the first example of from exercise 3.4. Okay, don't worry, I'll give you another 2 examples, alright, for multiplication before moving on to something harder. Okay, now let me start on a fresh page. Okay, I'll do 1D for you. Okay, 1D starts like this. -1, 0, 5, 0, 7, and -8. We will attempt to multiply this to okay, first and foremost, we must check whether these two matrices can be multiplied. 3 rows, 2 columns, 3 by 2 matrix. 2 rows, 3 columns. Then again, I do the highlighter, 2 and 3. Notice that yes, 2 and 3, they can be, their middle numbers are the same, which means that my resulting matrix will be a 3 by 3 matrix. So I shall prepare down here, it will be a 3 by 3 matrix. So there will be 9 numbers. Maybe I'll just do the top row for you. Okay, so top row, okay, maybe I do row 1, column 1. This guy here will be row 1, column 2. This guy here is row 1, column 3. And maybe I do this guy here also will be row 3, column 3. Okay, to get row 1, column 1, this element here, we take row 1, -1, 0, column 1, 3, 4. So -1 and 0, what happens is run and dive. So it's -1 and 0 will multiply to 3 and 4. So here I get -3 plus 0 is equals to -3. First element is done. Let me do for you row 1, column 2. Row 1, column 2, same thing, run and dive. Then column 2 is 1, 2. What I get is -1 plus 0. So this is -1. Similarly, for this element, row 1, column 3, run and dive, and here is 2, 6. I get -2 plus 0. This one is -2. Okay, now we can actually start to do this by mental calculation. Here, this element that I'm pointing to now will be row 2, column 1. So it's row 2, column 1. Run and dive will be 0 times 3 is 0, 7 times 4, 28. This one here will be 28. This one here, row 2, column 2. Row 2, column 2 is 0 and 14. So it will be 14. Here, row 2, column 3. Row 2, column 3, 0 times 2 is 0, 7 times 6 is 42. Last one, row 3, column 1, row 3, column 1, 15 minus 32 gives me -17. Row 1, okay, row 3, column 2, this one, row 3, column 2, row 3, column 2 will give me 5 minus 16, which gives me -11. And finally, row 3, column 3 is 10 minus 48 is -38. And we are done with question 1D. Okay, now I'll just quickly explain to you question 1B. Okay, I will not even do the run and dive anymore. So I just explain very quickly. 3, -4 multiply to 2, 5, -1, and 9. Okay, again we check whether it can be multiplied. 2 by 2 matrix, 2 by 2 matrix. Notice that the central numbers 2 and 2 are the same. So we can cancel the 2 and 2. My resultant matrix is a 2 by 2 matrix. So I prepare. Then 1, 2, 3, 4. Row 1, column 1 is 6, 3. Run and die 3, 6 will be 6 plus 30 is 36. Row 1, column 2. Row 1, column 2, negative 3 plus 54 is 51. This one, row 2, column 1, row 2, column 1, negative 8 minus 35 is negative 43. And last one, row 2, column 2, row 2, column 2 is 4 minus 63 is negative 59. Right, and that's it for the first part of multiplication of matrices. Okay, go and try and practice on your own to get the hang of this entire concept.